All right, what I've done is I put a few of the problems from this Chapter 6 study guide up on the board. We're going to go through those together. And then the rest of the time you'll have to work on your own, finish it off. All right, start with number 2 on that study guide. Number 2 wants you to find the sum of the measures of the interior angles of each convex polygon. And on number 2, we have a heptagon. So first thing we have to do is make sure we know how many sides a heptagon has. And that won't be given to you on the test. That's something you have to know. How many sides does a heptagon have? 6 is hexagon. 7 is heptagon, yep. So 7-sided figure. And then as soon as you see the words the measures or the sum of the interior angles, we're going to use the formula n minus 2 times 180. So when you see interior angles, think of this formula. We'll talk about exterior angles in just a second here. And now it's just a matter of taking the number of sides and putting it in for n. 7 is going to go in for n, so we have 7 minus 2 times 180. 7 minus 2 is 5. And 5 times 180 is 900. And that's all the further you have to go. If you add up all the interior angles on a heptagon, you will get 700 degrees. Now, if you go down to number 4, slide you guys over here so you can see it. Number 4, we're going to do interior and exterior. They want us to find the measures of an exterior angle and an interior angle on each regular polygon. And this time they give us a dodecagon on number 4. So we'll start the same way. A dodecagon, you have to know how many sides that is. How many sides does a dodecagon have? Andrew? 12. That one's going to be 12. And then what you're going to do from here, you could draw, this is going to be a regular dodecagon, so it's going to have 12 congruent sides, 12 congruent angles. You could draw the whole figure if you want. What I'm going to do is just draw one of the interior angles on the dodecagon. So this would be the interior angle. And then if I extend a side, this would be the exterior angle. And then you can go from there. You can either find the interior first or the exterior. If you want to do the interior first, you would start with this. If you want to do the exterior first, which I think is easier, then you could go this route. On any polygon, what's the sum of the exterior angles always going to be? On any polygon, Cooper? 360. So the sum of all those exterior angles is 360. Since we have a regular polygon here, all 12 sides and all 12 angles are going to be congruent. So to find one of these exterior angles, if they're all the same, we just take that 360 and split it up into 12 equal parts. 12 will go into 36 3 times, which is 36. Bring down your 0. That's going to go in there 0 times. So 30 is your exterior angle. And if you go about it doing it this way, now you can just look at your picture to find the interior angle. These two angles make a straight line, so they're going to add up to 180. And if you take 180 minus 30, that leaves you 150 for the interior. Now again, if you wanted to, you could start with this formula here, find the sum of the interior angles, divide it by 12 to get the interior, then subtract from 180 to get the exterior. So there's a couple different ways you could do it. In my opinion, this one's a little bit easier. All right, before we move on, any questions with that one? Okay, let's go to number 8. Some of you out here have your masks down below your nose. You got to get those up over your nose. You don't want people getting sick. All right, number 8. This one I want you to find the values of each variable for the parallelogram. So directions tell you it's a parallelogram. And then if you look at your picture here, we've got the two diagonals drawn in on number 8. And we should know our theorem here. If you have a parallelogram, what do we know about the diagonals? What do the diagonals of a parallelogram always do?
bisect each other?
They bisect each other. So they're going to split each other in half. These two parts are going to be the same, and these two parts are going to be the same. So you can start with x, or you can start with y. I'm going to start with x. The 4x and the x plus 6 will be equal to each other. You subtract the x here, we get 3x. And 6 divided by 3 is 2. And then to get y, we'll do the exact same thing. These two parts of your diagonal will be split in half. They'll be congruent to each other. 5y minus 8 will equal 3y plus 1. If we subtract the 3y, we get 2y over here. If you add 8 to that side, we get 9. You're going to end up with a decimal here. 9 divided by 2 is 4.5. And this is something that will happen quite a bit on this next test you're going to get to. There will be decimals for answers. So don't be surprised if you have a decimal for an answer. That does happen. Okay, let's go to 11. Number 11, directions tell you to determine whether each quadrilateral is a parallelogram and justify your answer. So on number 11, they're giving us the top and the bottom sides are parallel to each other. Do we have a theorem that says it's a parallelogram if you have one set of opposite sides parallel? Nope, we don't have that theorem. We do have a theorem that says both. If you have both sets of opposite sides parallel, that's by the definition of parallelogram. That would be a parallelogram. But we don't have a theorem that says one set of parallel sides gives you a parallelogram. So your answer here would be no. And then for your justifying, you just kind of have to explain it. I'm just going to say there's only one set of parallel sides. You could obviously word that differently and explain the same thing. As long as your explanation is describing what's happening here, you're good. All right, let's go to number, what did I put up here? Number 14 is the next one. Now, in 14, your paper has the graph paper on there. Mine didn't. I mean, I don't have it up here, so I just kind of freehanded it. They're giving you 4 points. What you're going to do first is plot those on your graph. So go ahead and put these 4 points on your graph. And then your picture, you can connect the 4 dots to get your quadrilateral. Your picture will look a little nicer than mine does. Anybody need more time to get those 4 points on there? Okay, so we got our 4 points. Here's R, it's at -2, 5. You went 2 to the left, up 5. Point O is at 1, 3. That's 1 to the right, up 3. Point M is at -3, -4. Went 3 to the left, down 4. And point Y is at -6, -1. That's 6 to the left and down 1. When you connect those, you get your quadrilateral. 14, they want us to figure out if this quadrilateral is a parallelogram. And they want us to use the slope formula to do this. Slope formula is going to tell us if our opposite sides are parallel to each other. And it doesn't matter which ones you start with. We got to figure out if these two are parallel. We got to figure out if these two are parallel. So I'm going to start with YR. Although you could start with any of them. And then to find the slope, if you remember, find the slope, we're going to subtract the Y's on top, the X's on the bottom. For segment YR, we have these 2 points. So my Y coordinates are 5 and -1. I'm going to subtract those two. It gives us 5 minus -1 on top. Then I'm going to go in the same order for my X coordinates, -2 and -6. We'll go -2 minus -6. And if you take care of your double negatives, those will become positives. 5 plus 1 is 6. Negative 2 plus 6 is 4. 6 over 4 reduces to 3 over 2. That's the slope of YR. If the slope of OM has the same exact slope, 3 over 2, then we know those lines are parallel. So let's check out OM and see what its slope is. Same thing, we're going to subtract the y's over the x's. That's going to be 3 minus negative 4 for the y's, and 1 minus negative 3 for the x's. Take care of those double negatives again. 3 plus 4 is 7. 1 plus 3 is 4. The slope of the first line was 3 over 2. The slope of the second line was 7 over 4. Are those two the exact same thing? No. So these are not parallel. If those two lines are not parallel, would I have to go any further? Nope. It's impossible to have a quadrilateral if these opposite sides are not parallel. So at this point, we can say no. And our justifying, our reason is I'm going to do some abbreviating here. Opposite sides are not parallel. All right, any questions with those? Okay, then if you notice, the next pages have your proofs on them. And I could go through the proofs with you on the board, but I don't think that's going to do a whole lot to help you remember this for the test next week. So I'm not going to go through the proofs with you. What I'm going to have you do is use in your study guide there, or in your packet we gave you. Go back a few pages, you should see a paper that looks like this. Got 3 proofs on it. Says parallelogram proofs at the top. These are the exact same proofs that are in your study guide. And this is the way it will be presented to you on the test. We'll give you the picture. We'll give you the given and proof statements. You're going to fill in all of the statements and reasons here. So this will be a real good practice to see how well you know those proofs. So if you get stuck on the proofs, I'll help you with those, but rather than me just going through and showing you how it works, like I said, I don't think that's going to stick with you very long if I do that. You got to dig in and work for it a little bit. You're probably going to remember it better next week. Okay, those of you that are here, when you finish that study guide, you're going to turn that into me or bring it back to the desk and show it to me. We've also got 2 days of notes, Tuesday, January 19th and Tuesday, February 2nd, yesterday. When you get done with all your stuff today, you bring all that back. We'll put it in the grade book today. Those of you at home, just hang on to it. You'll bring it in next week when you come to class. And that's it for you guys at home. You guys can go work on the study guide. We'll see you next week.